Hi and welcome back. In my last video I was talking about nonlinear filters, and in that video I made some mistakes, and I don't know how I did that because of I coded the patch before and I was reading the code while I was building the patch, and I don't know how I made terrible mistakes, and I want to fix them. It's a wonder that the filter worked the way it did. And it even sounded good because of the mistake I did, filtered out high frequencies. So aliasing was not an issue there. So it's kind of funny. It worked and it was not even that bad, but it's not good objectively because of the algorithm itself was broken. And here now you can see both of the filters at the same time, and on low frequencies they kind of match, but when I looked back on the video I've seen that on higher frequencies there's a dip in the response curve, and I'm going to move this frequency knob and raise the frequency, and then you will see that the orange line is going to dip, and there's a blue line below that which is going to go straight, and the blue is the correct one, the orange is the wrong one. So take a look, and here you can see that there's a huge difference in between the two filter outputs, and there is some dipping, and I remember that there is some, and this is why I didn't recognize it while I was building the patch, but yeah, this is not something that should happen. And on lower resonances the difference is huge, so it should have been close to the linear version when there's no resonance above or 1.95. So I'm sorry for this mistake. So now in this video I'm going to try to match the bottom filter to the upper one. And first we have to go into the stages and into the equation, because one mistake that I made was that I did put the multiplication, so I multiplied the resonance here. I shouldn't have. It should be really here. So we have to multiply y by k and add it to this. And the other thing that we should have done is so this result is okay, but we should have subtracted y from it. And the reason of this is that we have this equation, and to solve for the root, so we can put this into one equation. So the feedback is then this, which is P1 minus P2 and y is FP here, and then we have 1P1 once again there. So I know this is huge and complicated, but this is basically what is built here. But we need to set one side to 0. So if we set this side to 0, then we have to subtract the feedback from here. So this is why we have to subtract 0 from the end. So this way f is going to be a correct value. And now I replace this equation as well, and I'm going to do the same for the other stages. So I paste it here and replace, and paste here and replace. And this should result in a non-functional filter now. As you can see, we have no resonance at all, but doesn't matter, we will fix this. So the way we use the delta values is also broken, and we need to multiply the delta y by f, and then subtract the result of the division from y, like this. This is the way the second method works. So I do this in this other one as well. So we multiply here by f, we do the division, and subtract the result of the division from y. And this way I can replace stage 3 by stage 2, and instead of f0 we output y1 actually. That's going to be our feedback value. Let's take a look at this, and it's not that bad now, but it almost doesn't react to resonance because of we need to multiply the feedback by the resonance here, and look, we are starting to match. This is actually pretty close, there's some difference here, and that's because of the solver is calculating with the previous input sample, so we have to move the solver away from here. It will be in front of everything. So x comes into the solver, and then it goes into this multiplication by the resonance. And to keep this structure clean, I'm gonna paste the G input and the K input here, and create outputs for G from inside of the node. Also for X I create an output, and for G, and for the resonance K. And this way we can patch further, so I can plug X there, and plug G here, and K there, to keep the patch cleaner. And yeah, and we can also multiply K with K there. And this should be working. Maybe it's better to align this like this. Yeah, that looks better. And like this. And we are getting done in a minute, it looks like. So the low pass output is going to be this. Yeah, this is fine this way. I can't resist, I have to put a cone here, sorry. Yeah, let's take a look. We have to reconnect, since I recreated these plugs, I have to fix that. G comes there, and the resonance comes here. And it looks like there's something not okay. That's fine. What did I forget? Oh, I forgot the feedback itself. So S and Q have to be fed back, so they need to be the previous value. And yeah. This way the patch looks a bit better. It's a bit confusing that these lines go through everything, but done. So somehow I messed up the equation, that I didn't realize that I need to arrange the equation to 0. I forgot about it. I coded the patch or the filter months ago, and I didn't remember that. And for some reason I've decided to put the resonance in the end, because when I tested the patch it looked fine, but yeah, I see that it was broken. Anyways, this solution is now correct, and this should work fine, and I'm sorry for the misinformation. I hope I didn't harm anyone, and I'm trying to put this video as soon as I can out. So, and I will put a notification into the other video, or into the comment, or I don't know, into the description. Anyways, thanks for watching. These things happen sometimes, so bugs exist, and you can see that this is pretty complex, and it's easy to mess things up, and I'm sorry I messed it up. So if you like this content, then give it a like or a comment, or yeah, thanks for watching. Bye bye.